3, Lesson 5, Horizontal Asymptotes and L'Hopital's Rule. I can apply L'Hopital's rule. L'Hopital's rule is actually a limits rule you can use if you try to take the limit of some rational function and it results in an indeterminate form. So the numerator goes to infinity and the denominator goes to infinity or negative infinity. Or the numerator goes to 0 and the denominator goes to 0. If this happens, you will take the derivative of the numerator, separately take the derivative of the denominator, and continue this procedure until you no longer have an indeterminate form. Let's take a look. Find the limit as x goes to 0 of the following function. So you would plug in 0 to your top, plug in 0 to the bottom, and notice you get 0 over 0, which is an indeterminate form. What you should do in that case is you cannot write equals 0 over 0. That is not correct. You can't equal 0 over 0. What you have to do in order to apply L'Hopital's rule is show the conditions are true. So you have to write the limit as x goes to 0 of your denominator, your numerator, x squared minus 2x. If you were to plug in 0, 0 squared minus 2 times 0 gives you 0. And limit as x goes to 0 of your denominator, 3x squared minus 7x. So you plug in 0 and get 0. We call this our conditions. You have to show the limit of the numerator goes to 0 and the limit of the denominator goes to 0. Then you can apply L'Hopital's rule. Let's denote my L'Hopital's rule with a little LH just so I know what I'm doing. We're still going to keep our limit as x goes to 0. Then we take the limit of the numerator. And this is just simple power rule. It's not quotient rule where you're taking the derivative of the entire function. Its numerator is considered separate from denominator. Here we go. I'm going to take my derivative. I get 2x minus 2. And then again, using my power rule in the bottom, 6x minus 7. This time, if I plug in 0, 2 times 0 minus 2 is negative 2. 6 times 0 minus 7 is negative 7. And my limit is 2/7. Now I'm going to try the same thing with the next one. Limit as x goes to 3. I would plug in 3. I would notice pretty quickly I get 0 over 0. You can't just write 0 over 0. That doesn't actually work. You can cross it off and nobody will grade it, but you cannot write equals 0 over 0. You have to show that the numerator, limit as x goes to 3, of x squared plus 4x minus 21. If you were to plug in 3 gives you 0. And the limit as x goes to 3 of your denominator, x squared minus 5x plus 6 gives you 0. Now that you've shown those two things, please come to the high school main office. Any custodian, please come to the high school main office. Thank you. You can apply L'Hopital's rule. In other words, you can take the derivative of your numerator So I'm going to have 2x plus 4, and then take the derivative of your denominator, 2x minus 5. Now I will try to plug in 3 again. 2 times 3 gives me 6 plus 4 is 10. 2 times 3 gives me 6 minus 5 is 1. Therefore, the limit as x goes to 3 of x squared plus 4x minus 21 over x squared minus 5x plus 6 is 10. Now let's try the limit as x goes to infinity of 7x squared minus 7 over 2x squared minus 6x. Here, if I were to plug in infinity, infinity squared, still infinity. 2 times infinity squared minus 6 times infinity. Still got a lot of infinities going on in there. So I have infinity over infinity. But again, you cannot write equals infinity over infinity. You have to show limit as x goes to infinity of your numerator. 7x squared minus 7 is infinity. Anytime you plug infinity into a numerator, and for a variable like x, it's going to go to infinity. And then again, show it for your denominator. Limit as x goes to infinity of 2x squared minus 6x is infinity. Now we apply L'Hopital's rule. I'm going to have limit as x goes to infinity. And then I will take the derivative of my numerator. I will get 14x over the derivative of my denominator, which would be 4x minus 6. And again, I still have those x's. So I'm still going to be going to infinity over infinity. This means I'll need to apply L'Hopital's rule. So the first thing I have to show again is the limit of my numerator goes to infinity and the limit of my denominator goes to infinity. You must actually write this down again. Now, you can apply L'Hopital's rule again. You can take the limit of your numerator and separately take the limit of your denominator. Derivative of 14x is 14. And the derivative of 4x minus 6 is 4. Here, I don't have any more x's. So I don't really have anywhere to plug infinity into, which is actually good. That means the limit as x goes to infinity of my original function is just the ratio of 14 over 4, or reduced, 7 over 2. And that's how you would apply L'Hopital's rule.